So example 7 says to verify the identity. And so we have sine of x cosine of x over 2 equals sine of x over 2 times 1 plus cosine of x. Now what can we do? First thing I notice is on this side we have these two different types of angles, right? So what do we know about x compared to x over 2? X is double x over 2, isn't it? It's twice the amount. If I take x over 2 and I multiply by 2, do I get just x? Yeah. Okay. All right, so we've got to pick a side to work. So which one do you want to try? The right. The right? All right, let's see. What can we do? Well, let's see. What if we distribute? I don't know. I'll work the other side, so let's see what we can do from here. All right, because the 1 plus cosine didn't get me anywhere, right? Now, sine of x over 2, we might want to go back and use half-angle formula, but the half-angle formula has a square root in it, doesn't it? So probably not. But that's not saying that we couldn't. Do we have any formula that this would help us, or would help us with this? So don't look at it necessarily as an x over 2, but think about if it said sine of an angle plus sine of an angle times cosine of twice that angle. Sine of an angle plus sine of an angle cosine of twice that angle. I'm not seeing anything. But we did say this would be a double angle then, right? I may be, taking a scenic route here. I may get stuck, but if that's a double angle, could we try to use a double angle formula? Okay, because remember, how about let's do this. So this is the same as saying x sine of x over 2 plus sine of x over 2 times cosine of 2 times x over 2, isn't it? So what if I try to put a double angle formula in here? So cosine of 2x. Well, which one do we want to use? There's 3 of them. I'm getting a little nervous because I'm just going to pick, I don't know, I need a sine of x, so I'm going to pick the second one. Just apply again.
But then you'll get rid of the cosine.
I did get rid of cosine. Good point. So let's try the one with cosine instead. I didn't catch that one. All right. So, all right, we can use the first one. All right. But I don't need anything squared, do I? So what can we do on that? What do you mean expand it?
Oh, like bring it down.
How? Well, I don't need that power, do I? So what if I reduced it to a 1? That would be a power reducing formula, wouldn't it? Let's try it. So I'm not going to touch anything here in front of it right now because if I start distributing, I'm going to make it look messier. And I'm not real sure where I'm going with this anyways. So let's try that. Cosine squared. Power reducing says you take... Well, hold on real quick. Let me go back up a step. Here where I put cosine squared of x minus sine squared of x, our x is really x over 2, isn't it? Because remember that was cosine of 2, and that was our x. Alright, so when I go to do that power reducing formula, for cosine squared, I see it's 1 plus cosine of 2x, which is really our x over 2, minus, if I do the sine squared as power reducing as well, it's 1 minus cosine of 2x, which our x is our x over 2, all over 2. So they got a common denominator, so I'm going to distribute. And this time I put x because it's 2 times x over 2, which means it's really just x, isn't it? Well, I would ask if we did something wrong, but y'all don't hate me for this, but watch this. If I common factor out a sine of x over 2, I'm back where I started. We just did a full circle. Yep. I told y'all it could happen, didn't I? Remember the other day? We did it. All right, so what that tells me is maybe I need to go work on the other side. Okay, since I did a full circle, maybe I'll have something here that matches up. So let's go work on that other side. Now, we had said that this x is twice the amount of this. So how about I first just rewrite that? So this is sine of 2 times x over 2 times cosine of x over 2. And let's see, if I do that half angle formula, I'm going to get a square root, and I don't want that. So let's work on this one. So let's use our double angle formula. Sine of 2x is equal to 2 sine of x cosine of x. So this is going to become 2 sine of x, which is x over 2, cosine of x, which is x over 2, times this cosine of x over 2. Sorry, I'm having to squeeze it in there. Well, I've got 2 times sine times cosine, right?
Where did the other cosine come from?
This right here is the double angle formula.
Okay.
Okay? So I'm going to go ahead and let's just multiply our cosines together. So 2 sine of x over 2 times cosine squared of x over 2. But we don't need that square, do we? So let's try using our power reducing formula. Y'all need to pick your head up and pay attention. Alright, power reducing formula there for cosine squared says 1 plus cosine of 2x, which is our x over 2, all over 2. I should have used a different color on the side. So I can simplify what's in the parentheses there a little bit. The cosine of 2 times the x over 2, the 2's are canceled, so I get 1 plus cosine of x over 2. Now what?
We need to get rid of that 2.
Right, well look, this times this times this, right? Does the order matter in multiplication? Is 2 times 3 the same as 3 times 2? Yeah, so could I multiply this 2 times this fraction first? I can. And what happens when you have a 2 on top and a 2 on bottom? They cancel. So those 2's are going to cancel. So we're left with sine of x over 2 times 1 plus cosine of x. And oh, that's what we wanted, isn't it? And that's equal to what we started with. Well, that was fun.